Yeah, 7:26. I'm late if I were going to be here at 7 o'clock. But tonight we're going to talk about intake manifold designs. The thumbnail that I have up is actually from, so the question is intake manifold, like angle of attack. So how does the port on the intake manifold, how does that angle of attack into the cylinder head, how does that affect performance? So basically does like, cross ram style manifold, does that work better than if the same manifold were straight up and down? Like if you think about a high ram versus a cross ram, tunnel ram versus a cross ram, are those the same thing? If there was a way that we could package the runners exactly the same, just one of them laid over or one of them straight up and down, which one of those would make more power? Again, we have to assume a couple of things: that the plenum volume, in air quotes, would be the same and the throttle body would be the same. But here's the thing: it won't be. I mean, it can't be. If you, depending on how you have the runners positioned relative to what's going on in the rest of the plenum, you're going to have a different angle of attack for the air entering the plenum. Like if you take a look at a high ram or something, or most of these types of tunnel rams, either they're both coming down from the top on a carburetor, or you have a front mount like on the high ram with a throttle body for fuel injected things. And on these cross rams, the cross rams laid over, and traditionally you have the air going in to, I mean, it's a common plenum. People think that the air comes in and hits all these runners and moves around and bounces around. That doesn't really happen. What happens is the air from the throttle body fills the plenum, and then the runners are taking it, are drawing from the plenum, which is creating vacuum and then adding more airflow. But I digress. So the air entering in there, is going to have to be different. My question really, though, is I've built a lot of different custom intake manifolds, most of them adjustable, just because that's my jams. And I like to see what happens when we do longer runners and shorter runners and that kind of stuff. I like to show the changes in power curves. But I've often thought about, when we look at these, the way that the cylinder head is, some of them, even though, for instance, on a 462 valve, even though the flange for the intake manifold, the way that they have it on the cylinder head, is flat, but the port is like at a weird angle to this flat plate. So if you make a flat plate that bolts to that and you make the runner go straight up, it's going to be at a weird angle relative to the head port. So it's got to come in and make a turn. Is that optimum? Should the runner come out, if the angle of the head is like this and the plate is flat like this, should the angle of the port come out so that it's, a nice straight, no transition kind of thing going into the port? Should it be like that? Is that the best way? And we see this in a lot of stuff. The modular forge are a good example. The LS, to some extent, more on the LS, because of the way that it, if we look at the head facing, it's kind of at an angle, and then the runners, it's like on a fast or this performance design manifold comes in at a fairly straight angle toward the direction of the head port toward the valve. But a high ram doesn't do that. I mean, it makes a bend and comes straight up. So is that problematic? If you put the bend in and the bend is correct, and you have the proper airspeed, does it become irrelevant? Does it not matter? In my opinion, it doesn't matter greatly, at least in the testing that I've done. Now, I haven't done specifically like taking the intake manifold that had a turn in and just bended it straight and to see if that angle of attack was better. Again, I think what we're talking about here is the runner length and the flow of the manifold relative to what we're trying to achieve with the motor. If this is a 400 horsepower motor and we have 600 horsepower worth of airflow and the right runner length, then we have way more than we need. So doing little things to it, not really going to help. But if you're building a Formula One motor, those are things that you need to consider. And then the question becomes, if it doesn't matter here and it does matter way up here, where does it start to matter? Where does that become important? And then also, as it always is with any of these discussions, if it does matter and you want to make the thing optimum, they want to make the I call it the angle of attack, the entry angle from the intake manifold port to the head port, and you want to keep that consistent at the same angle. If you want to do that, that's fantastic, and think it'll help. That's fantastic. I'm right there on board with you. But can you do that? Can you do that and then make it package? And I remember trying to you go through this, doing it with a CAD program or something would be SolidWorks or whatever that they would have now that's not 100 years old, would probably be a lot easier because then you could just do it on a computer. But when I was doing it back in my day, I did it with aluminum tubing and bends of aluminum tubing. And then you have to, I would draw it out. I would hand draw it and then figure out and measure and mock up and see if, can I make all that work? Can I have the bend that I want and the angle that I want? And then after that, can I then make that all of that fit if I'm trying to make it package for a given application, like the stuff that I did for the 3-valve manifold, which fit under the hood and worked, and the stuff that I did for the 2-valve non-PI deal, that we had all that worked and it fit under the hood and it worked. Can you do that? And then that becomes the issue. Yes, we all want nice, stacks and the right kind of bend and the right angle of attack and the entry and stuff. But sometimes you just can't do that. You can't do that and have it be a production, especially when you have hood clearance issues. You know, if it's a race only thing. And then even at the highest level of stuff, can you fit that in a pro stock motor? Do you have, do you have hood clearance for that? For Formula One, packaging is a critical element because there's so much aero consideration. So you have to work around those constraints. Hey, you have just free reign to draw the motor out any way that you want and make it the most power. Okay, that's terrible aerodynamically. So now we need to make it so it's way too heavy, it's way too cumbersome, it's way too bulky, and it's too high of a center of gravity. It has all sorts of other problems that are wrong with it. Yeah, but it makes the most power. That's great. That's one thing. We need to do the 10 other things now, and so you're gonna have to have a compromise of all those things, and whatever the best thing is, like for Formula One, a little more lenient for drag racing because they don't have that same kind of consideration. The ultra lightweight and packaging and the center of gravity and all that, and not a lot of that stuff is not really a concern, obviously. But and then the OEM level, you have that same thing. It's got to be, it's got to get good fuel mileage and idle and NVH and all of these things. So it's a difficult task. Yeah, for me on the dyno, if I'm only trying to package it on the dyno, it's a piece of cake. You can do whatever you want. You can make them go all different ways, and you could have a lazy eye over here and just all kinds of things happening. Because as long as it fits, and we have a ton of room in the dyno to make all that happen, which is why I think in 2024 that I should do some more crazy intakes. So I want to step up my crazy intake game and do some more fun stuff because, why not? It's kind of cool. And people want to see, crazy super richy stuff. So I think there needs to be more of that. I think that there needs to be some really long runner stuff and some crossover stuff. And maybe I'll make my own like Sonic Ram kind of thing. And I've got some ideas. So there's never any shortage of ideas. Then you just have to execute them. And, that life with everything that just all it takes is time and money, right? And then you can make all of that work. So we'll see how everybody's doing here on a Saturday night. Hopefully you guys have some good questions. Cross ram, IR for the win. That's another consideration. If you do the cross ram, like the one that I was showing for the Performance Design intake manifold, is a cross ram housed inside. They have a clamshell, basically a lid that goes over the top of it, and so that it's housed inside a common plenum. And the fast manifold is like that. The LSXR, the LSXRT, they're very similar, and most OEM manifolds are like that too. The stock LS4 truck, LS6, LS2, LS3s, all the LSs, Trailblazer SS, LS7, all of those are essentially like that. just they don't have a two-piece design. It's all a it's all a molded piece as one thing. But it's the same deal. It has a common entry for the throttle body going into a common plenum, and then in a lot of these cases, wrap around cross ram style intake manifold or the runners, so that they get lots of runner length, because none of these things are making power at a very high engine speed. They don't need to. That's why we have, we're exercising our God-given right to drive a V8 automobile. Twin 112s on a Sonic Ram, not 112s. 112s are just way too much money. They're you don't find them very often. And if I was going to do it, I definitely would do common ones for 90s on it. Isn't length just length? I guess that whatever is the straightest way into the valve is better. Yeah, we kind of went over that. Let's design an infinite length intake runner. Yeah, that's going to be hard. Old Smoky Eunuch, small block Chevy cross ram was a neat piece. Yeah, and the factory cross ram for the small block Chevys. Skyram, yeah, we could make something a lot longer than that, and something that doesn't come apart or catch on fire. That would be better. I'm wondering how they got more flow from 120-degree swoop than a straight bell mouth flange. On what are you talking about? Got a Boss 290 intake. Those are cool. A Navigator 4-valve. Be willing to let you test it if you had a need. I think I've run that Boss manifold before. I'm curious as to how it flows modified, like it has been modified for twin TV, twin 4-valve, or what? I don't know what the TV part of it is. Twin throttle body. Make an internal velocity stack around each intake port. If you've seen any of the manifolds that I did, we have full radius air horns at the entry of all of the runners. What's the best way to make monster torque? We've talked about torque production a lot, but boost, displacement, compression, not so much cylinder head and camshaft. Intake runner length, definitely. All of those can really help with torque production. Does long ram and short ram even matter under boost? Yeah, it matters no matter what. It does the same thing under boost that it does NA. Sonic cross ram with a vacuum operated chamber switch to make it shorter. I think I got something there. The old stack injection Crowder Hillborns, they were very effective, yeah. And they had different diameters and stuff that you could, and different lengths that you could run. Certainly reversion should be taken into consideration in open IR configuration. Do you mean runner length should be taken into consideration? Should test a stack 671 Roots blower or twin ProCharger. What do you mean by stacked? Do you mean one Roots blower on top of another? How about a draw through carb to supercharger with a blow through turbo into the same carb? So you want to run a blower with a carburetor on top of it, and then a turbo blowing through that carburetor that's on top of the supercharger. That's pro street stuff. That can definitely be done. Lyndon, what's up? Let's see a VS Racing versus FIS turbo test. Yeah, I saw that. Gale Banks on their test of the Monster Ram intake air horn over a straight velocity stack. On what did they test that on? Is that a single opening stack on something that they tested it on? Was it a runner length or what? I'll have to look that up and see what you're talking about. Flow size volume matter can more with wet flow, not so much with port EFI. Julius is in the house. What's going on, man? Cottingham, you should have asked John to see the data about the statements that he was making. I know he's friends with the FIS guys and doesn't like VS Racing the same way that he doesn't like the guys at Sloppy Mechanics. But as we've seen in the past, that when he makes an absolute statement like that, he doesn't generally have data to back that up. So I'd like to see the data on what he says. I'm not saying that they're not better. They may well be. They may be more modern design wheel and all that. And it would be hard to do a test where you're comparing one versus the other, because I don't know what the test would want to be. I don't know if you'd want to have everything the same. Is the opening, the compressor housing the same? Is the AR the same? Is the exhaust the same? Would it only be the wheel? Would it only be the compressor wheel? Would it be the turbine wheel? Like a turbo is there's a lot of potential variables for one of them being better than the other. But I would like to see, as always, test data where that's proven out, and guys using anecdotal stuff about, oh, this guy runs 590s or what, that's not data. Twin blade throttle body to the passenger side, Boss 209. Sorry, had a drink or two. I have never experimented with nitromethane yet. Could we test a manifold fitted with a carburetor for main fuel duty and EFI to clean up distribution in each cylinder? Get both benefits of fuel cooling and cylinder distribution. Eric tried to do that and he didn't do it with a carburetor. They did it with like the 4-hole throttle bodies, and then also sequential port injection. But I don't know how successful it was. Given the way that, I think you'd get gains from injecting fuel, obviously, into the intake manifold. So you'd have that. But I don't think you would see from tuning up the individual cylinders after you did that. I don't think you'll see big changes in power. Just like we didn't see that when it was fuel injected. You didn't see big changes from the air fuel in one cylinder going from 14 to 1 to 13 to 1. There just wasn't the big change in power, but there would be a big change in the piston lasting for very long if you were at wide open throttle for an extended period of time. Richard, have there been any testing done with the early 80s Corvette cross ram with modern EFI throttle body systems? The limitation for those wasn't so much in the computer speed and stuff as it was the flow rate of that intake manifold design. There are two problems with those cross rams in they wouldn't have been early 80s though. They would have been, right? Yeah, 84 and 82, maybe 81. So yeah, you're right. Early 80s. For some reason, I was thinking that's 89, 90. But that was an L83, at least in the 84 Corvette. The ports on those were very small, where they connect to the cylinder head. Also, the throttle bodies themselves were very small, so you could pulse the fuel and do the timing enough to make the maximum power out of that setup. You'd need to modify the setup, the airflow into the manifold itself, and then the ports in the manifold, and then look at the actual design of the manifold. I think it'd be better just to do a new lid, and I think guys have done this, put 2 carburetors on it. But then, because the port exit of the intake manifold, or the entry of the cylinder head, is so small that it doesn't really match up very well to any sort of performance cylinder head. Does a 4853 or 60 care about how big the plenum is? I haven't seen changes, any significant changes in power from plenum volume on any of the LS stuff that I've tested. Runner length, however, makes a big change on all the displacements. And the runner length is going to help determine your effective RPM range working alongside the camshaft. And you want to see 2 Roots blowers stacked, so it's going to be a compound deal. That's not going to be very effective. It'd actually be way better to have 2 blowers side by side feeding the motor, so that you're doubling the airflow. I'll read the first part of your statement, Brett. In your opinion, what's the best exhaust manifold for a single turbo LS? You'd have to define what you mean by best. There isn't, if you're looking for somebody to tell you that one manifold is going to make more power than the other, you're looking for power in the wrong spot. You need to be looking for power from a turbo combination. You need to be looking at the turbo. You also need to be looking at the NA power. And then we've talked about this many, many times. If you want 1,000 horsepower, you put 1,000 horsepower turbo on it. And then how much ever power your NA motor makes is going to determine whether you make 1,000 horsepower at 10 pounds or 15 pounds or 20 pounds. There would ultimately be a limit to that, but everywhere in the sweet spot range. So if you have 1,000 horsepower turbo and your NA motor makes 400, you can make 1,000. If it makes 450, you can make 1,000. If it makes 500, you can make 1,000, and so on. The exhaust manifold is not going to stop you. You can go way into 4-digit stuff with stock truck manifolds. So anything else that you'd put on there is going to benefit you. And if you have 1,000 horsepower turbo, any sort of header or whatever, or exhaust manifold you put on there is not going to take you beyond 1,000 horsepower, because the turbo is going to determine that. Oh, on a 416, would cathedral or rectangular port be better for the street? I don't know what people mean by better. If you were to tell me how much power you want and where you want that power, then I could tell you which one of those to use. Either one of those heads will work good and make good power. Cathedral ports traditionally will make more power at a lower engine speed. So in our testing, depending on what you're doing with the rest of the motor, but say from 3,500 maybe, or on a 416 and down, better there. But again, by how much? If I had one of the heads, if I had rec port heads, I wouldn't buy cathedral port heads to try to do better than the rec port heads, because if they're stock, you're not going to do that anyway. To make better power than a stock set of rec port heads, you'd have to go to an aftermarket like CNC ported or ported stock heads. They'd have to be ported, and they'd have to be done right to make more power than the rec port head does. The rec port head will be a little bit softer down low. Also because the rec port head has a big chamber too. Same boost, same back pressure, everything close as possible. Yeah, well, and that's easy to say, but it's hard to do. Because again, if you pick 2 turbos and one of them has a little bit different hot side, the back pressure is going to be different. If the boost pressure is the same, the back pressure is going to be different. That's not a function of one turbo being better than the other, or an impeller wheel or a turbine wheel being better than the other one. It's just different and bigger, probably. I'm using that as an example. That's a possibility. So like I said, the ask that was there on those comments when you guys were going back and forth is a difficult thing to directly compare, unless you can find a turbo where everything is the same. Like, the best thing to do would be to run the turbo, take the wheel off of one, put the wheel from the other one back on that one, and then test it. But here's the problem. That wheel was not designed with that housing in mind. That wheel was designed with another housing in mind. If the turbo guy is, and I'm sure that these guys are, are sharp at what they're doing, and I'm sure both of them are, that the wheel would be designed to match what's going on with the housing. And so doing it my way wouldn't probably work very well, wouldn't be idealized. But in testing, I like to minimize the number of variables, and it's so hard to get it down to one thing. Saul, thank you very much. Air temps are going to be close, being that exhaust runs the turbo, so less heat in the charge is less efficient because you want hot air in the exhaust. The air temperature is going to be primarily a function of the boost pressure. It's going to be a function of the two big things that are going to affect air temperature are the temperature of the air going in and then the boost pressure coming out. The wheel efficiency, I'd like to see a difference in air temperature based on a wheel change with the same boost and the same inlet air. I'd like to see that. I'm not saying that it can't be something that would be measurable, but I think it's a little thing and not a big thing. Yeah, Burns, I plan to do a thing where we do another injector movement thing. I'm going to do something that's pretty cool that's not in the industry yet. So we'll see. And it might even be offered for sale. I'm really curious to see how some aftermarket turbo companies can rate their turbo at way higher horsepower levels than Garrett or Borg, even though there's no data to back it up. The only thing I would say about that is if they can, two things. One, if they've taken that turbo and actually made that power, and the turbo guys, the manufacturers, the guys that are doing the turbos should be smart enough, and the guys that I've talked to definitely are. You would realize that if you're going to do a high horsepower thing to rate the turbo, you would put it on a 2JZ or an RB or something like that, something where you could max the turbo out. And on a smaller motor, you're going to end up making more power, assuming that it has the right map and pressure ratio and all that. But, if you put it on a 6-liter, it might not make as much as it does ultimately on a 3-liter 2J motor. So you would do that. But that's the thing, a lot of people look at those and think universally that, hey, look, this thing's rated at 1,000 horsepower. Well, yeah, but it's not going to do that on a 454 or a 496 or a 596 because you're going to run out of hot side flow before that even happens. Ain't no cross ram like a big block Chrysler cross ram. Yeah, the Sonic Rams were the ones that we're talking about that we really, really like. With all the very large intake ports on late model engines such as LS and LT, is a myth that large intake ports kill low end power, or is it fact? That's as an absolute statement, that's not true. You can't say that and again, there's a lot of things going on there. You have to define what you mean by large intake port. What area, cross section, size, shape? What do you mean by that? And then what is it relative to? Is it relative to, are you just talking about LS3 versus cathedral port? Completely different shape and different port, total volume and pinch point and all valve size and all these things that are different about it. What I would ask you to do is go look at imports. Go look at a Honda. Go look at a B16 or a K series, even more. Look at the size port on that head and look at the flow rate of that head relative to its power output. Anybody know the difference between a C4 700R4 trans out of a Corvette and, let's say, a 700R4 from a Caprice? And the other thing I was going to point out on the turbo stuff is guys are sharp enough to rate their turbo using an optimized motor to do it with. But also Garrett and those guys may intentionally underrate their stuff. I've run across that a lot. Like with the Vortec guys, when you take a look at their blower and they have their flow rates and this is how much boost it'll support and this is how much power it'll support. None of that is what I would call accurate. It's accurate for them, but everybody that I know has gone way beyond that. And it's probably this, and I would imagine it's probably the same thing for Garrett. Isn't a cross ram effectively a chop tunnel ram where you don't have hood clearance? Yeah, that's what we were talking about. Is that the thing? Is that really a deal there? So we'll have a poll, and that's going to be the poll. Your statement, your comment will be the poll. Is a cruise ram, man. Is a cross ram just a lazy tunnel ram laying over to take a nap? Phrase. Laying over to take a nap. And away we go. There's a YouTube short that has a King Cobra with 3 roots blowers and twin turbos on a 347. That's what you need, right? Blowers blown into blowers and turbos. That kind of stuff was pretty popular back in the Pro Street days. Realistically, we just want the port to aim straight into the cylinder, so we do whatever we can. It's possible to have too big of a plenum. Well, if you take a look at the Keglodon video where I had plenum volume that was the size of, literally, the size of a beer keg, it didn't affect power at all. Sorry, I was reading something. I heard a little cathedral ports tend to make more power down low and rec ports make more power up top. I thought cathedral ports did better all around. That's not accurate. How do you like the Pulsar turbos? I don't think I've ever tried them. Did you see the Garage 54? See the Garage 56 Camaro pictures of the airbox? It's really sensible setup. I don't know. I didn't see it. Burns, you're in. Where's the kickstart? I would imagine somebody else would sell it if I did that. Like 50 to 60 PSI, but on a V8, it would be out of the map. Well, we just need to put the right turbos on it, right? We just need to compound it. AJ, someone needs to make you brackets to invert a junkyard M90 so it blows up into an elbow like the Ford M90 so that you can run a remote air to water like a turbo. That's pretty easily done, actually. I could do that with the, yeah, and I think you'll like what I'm doing with it coming up here. In January, there's going to be some, fun things. So you'll like what I'm doing with one of the M90s. And it will involve pickles too. Blue collar on a service call. I look at compressor maps and shaft speed. I'd rather not overspeed the turbo just to hit a horsepower number, especially when eBay turbos were so cheap. And that, Bill, as you know, that's not uncommon. because when people are trying to get everything that they can out of the turbo, that's where they go. They go too far to the right side of the map where there's trying to get lots of flow and lots of speed and lots of problems. On a twin turbo application, is the turbo rating added to get the rating of the turbo? Yes, if you have you should only think about it in terms of turbos. If you have a 500 horsepower turbo, it can make 500 horsepower turbo. You can make 500 horsepower. If you have another 500 horsepower turbo, now you can make 1,000 horsepower. And so that's the way twin turbos work. 20,000 likes and Richard has to blow an engine up on the dyno with a Dorman intake manifold on it. So do you want the Dorman intake to blow up or do you want the motor to blow up? Me personally, I'd rather see the Dorman intake blow up, but that actually might be hard to do. I mean, we've run 28 pounds on a fast. The Dorman, you would think a Dorman would be that strong since it's a one-piece manifold. What's the biggest inlet port you've run on a 5.3? I think the biggest 5.3 stuff that I've run, well, if you look at I think the port on the L83 is pretty big, isn't it? Not on a cathedral port would just be that latest 220 head that I ran on there. I've run 215s on a 5.3. We've run ported 243s. That's probably a 235 cc intake port. And then the ported 220s we've run on there. None of which, by the way, is anywhere near being in the too big range. I've seen people moving their fuel injectors to spray from inside the plenum towards each other, towards each cylinder. Yeah, that's pretty normal. That does what a carburetor does on an intake manifold. Scrolling back here, valve body differences. Simple mods, what do you mean by that? Is 800 horsepower on top of the base horsepower? Okay. Two 400 horsepower turbos means you can make 800. Yep. Crush factor. The total would be 800 unless you do a compound. Been watching a long time. 15 doesn't burn a hole in his pocket. Just saying, I appreciate it. Thanks, man. I appreciate it. I'll get a frosty cold beverage on you. What's the difference between a Cobra 4-valve and an Aviator 4-valve? Just a built bottom end. You asked that question already. I answered that question on the because you asked that on the comments in the videos. And I think I answered that already. 40 to 50 psi on a 4-cylinder on that turbo. You can run that turbo on a V8, just would tap out sooner. Pro Street, the J2000. Yeah, that's a pretty famous one. And nitrous backfire will take care of the Dorman intake. Yeah, definitely will. I've been told many times that multiple throttle bodies are the hardest to tune. Do you feel the massive power gains that's normally seen are worth it? I don't know about massive power gains. I think that if you're talking about an individual runner setup, they're really cool. They look good. And we've talked about them on the live feed before. They're problematic for a couple of reasons. One, air cleaner assemblies are problematic and restricting flow and not looking good and all that. And then syncing them all to make sure that they all open at exactly the same point. Once they're at 75% throttle, and maybe even 50% throttle, it's not really a big deal. But when one of them is open 1% and another one is open 3%, it's a huge change in the way that the drivability is. And it's a huge change in the air fuel of that cylinder because it's getting the same amount of fuel as the one that's 1% open. And so that part of it is really problematic. getting them all lined up and synced and machined, and so the blades are all in the original position to start out with, and that when you move the throttle linkage, like a lot of these IR deals will have a center pivot linkage, which seems to work fairly well. And then are they all, tight enough on a common shaft that when they open up, they all open up exactly the same, and you got to go through syncing them and stuff. So it's a little bit of work. How do you know how much power you can get from? I'm sure that's stock internals. That's why I do those big bang tests. Supercharged twin turbo big block and a Nova. Garage 56 had ITBs on a SB2, and the throttle shaft assembly was inside the airbox, all filtered air. That's good. Cross ram is a tunnel ram, but with more runner length and better looks. Cross ram doesn't have to have a lot of runner length. I mean, it could be a short runner one. You look at the adjustable fast manifolds, the short runner sections obviously are probably shorter than tunnel ram is, shorter than a high ram is. Camacho cold deal, yep. ITBs are awesome and worth it, but it's more about the response and the coolness factor. I still have installed or fired my twin turbo supercharged big block. See, he's doing all of it. He's going all Pro Street. The life of a city utility worker. Current situation: down one pump at a lift station, sparks out the electrical panel. It's going to be a long night. Good luck, blue collar man. Have you tested the Phytech intake manifold? I have not. Aviator got the Numac block, which the Cobra never got, and some even got a forged crank. 04 and 05 Aviator's got the Numac. On the Aviator, didn't they have different camshafts? And did they have different compression? And and obviously they had different intake manifolds, right? Richard, I'm building a twin 75 millimeter turbo 5.3 with a Holley cross ram. So like Matt did at Sloppy. Curious if running the cold side directly into each throttle body be temp concern or run with an intercooler. If you're running a turbo or turbos, you should have an intercooler. So the kind of intake manifold that you're running it into doesn't make any difference. I'm actually looking into running ITBs on my Corvette. Make sure you think about one of the things that we saw, and the guys at Westech have had Corvettes and stuff come in and other cars, chassis with ITBs on them. And one of the things to be concerned about, we don't have this issue on the dyno, but in the car with the hood closed, and let's say you don't have any air cleaners on it, the way that the cross ram works, the opening is directly above where the headers are. So the air going in can get hot. So it's something to think about. Your test of the Edelbrock LS crossover ram was interesting. It has those weird crossover ports in the plenum, and those are a good idea. Communication ports between the two plenums are a good idea. Any experience with 3D printed intake manifolds? I have not. Admiral, does an Aviator have Cobra or Cobra camshafts in it? I have a 62 Suburban that I got, a 6-liter LQ4. Should keep it straight swap, or is there easy upgrades to do while I have the motor out? The best thing to do to a 6-liter is a cam and springs that's going to make the most power. AJ, for a 4.3, I should get full-size truck exhaust manifolds. Okay. I could just take those out. I did notice when taking the motors out, getting them out of vans is much more of a pain than getting them out of trucks. So we kind of like to get one out of a truck anyways. Too tall. Thank you very much. The only Cobras that had different cams from the other 464 valves is the B-headed Cobras. I want my Suburban for mostly towing. Even a stock one works good, but like if you put a Truck Norris cam in there or a torque cam or something, it'll be better. I learned communication parts between the two plenums is a good idea. Yeah. It changes the power too. Yeah, Admiral, high ram is not, that's a higher RPM manifold. Not as high as a low ram, but higher than certainly that cross ram and in any of the fast or Trailblazer SSs or any of those. Truck Norris cam and what springs you recommend? Well, if you get, depending on what 6-liter you have, if you get a Truck Norris NSR cam, you don't need springs. You could just use the stock springs. What I would recommend for that camshaft is at least put the LS3 springs on it, the 550 lift springs, or Brian Tooley has Beehive springs that work good. Or if you get the regular Truck Norris, you could use the Beehive springs, I think, or they have dual springs. They'll be able to hook you up with that. Aviator has the same cams as the 99 to 04 Cobras. The trick we used in 6-cylinder class racing that did not allow headers. Not sure how much power it had. You guys never tested it on the dyno or anything? What is the LT1 intake that is considered a tunnel ram? I don't know about the LT1. Can you bore a 5.3 aluminum block out? Yes. But not the other ones, though. Not very much. I think with a crossbow that you can shape the runners into a Venturi effect when coming into the head to get more air. I don't know what you mean by crossbow. Crossflow, maybe, yeah. But I don't think it would be crossflow either. Cross ram, maybe. Yeah, that's what I'm thinking, Burns. Cross ramage. How's your pole doing? I haven't even looked. Is a cross ram just a lazy tunnel ram laying over to take a nap? Yes, 74%. Lazy cross rams. Even the compression's the same with all those. Okay, I thought that they wouldn't have done that on the Aviator motor. Holy crash rams for LSs will work on different deck heights without an adapter. Yeah, because they're separate, right? Crisscross will make you jump. DSM will make you jump. Sound Machine. Yeah, I just watched Pitch Perfect too. With Falula. Watched video last night of a guy riding a truck say BTR used the wrong formula and used Richard's dyno sheet. That's me. Proven LSA, one cam at a time. Crossbow would definitely have an effect on runner number broadhead porting. I am down with OPP. Yeah, you know me. Das Sound Machine. Current level OEM tech is equal to what era Formula One tech? I don't know. I think if you were to look at the power outputs of specific displacements, it could kind of get you an idea, but they're doing such different things that you can't directly compare them. The J Series NSX is back together. He hurt an axle and then had to have two of them. He had two of them fixed, and so he was going to run it at the track this last weekend, but it was too cold. They got some freezing weather, and so he's going to take it back out and run it again. Backward pants and before the parachute pants. That's right. He was all hammered out. AJ, unopened. I was hoping it was gonna say unopened coyote because I likes me some unopened coyotes. 96 Vortec with truck manifolds, 160 degree thermostat, Hypertech tuner, nice. 3-inch single exhaust through Dynamax race bullet, made 170 at the tire. 4 high and an all-wheel drive dyno, 33-inch tires and 342s. That's very cool. S10 Blazer. Hypertech. So how much timing did the Hypertech tuner chip or whatever add to it? Because was that a flash program? 96 might be a flash program. I was hoping that it was a plug-in EEPROM. Have you ever had a cross-ram accumulate oil in the plenum? It'd be really easy to do. All you have to hook up is a PCV to it, and it will definitely accumulate oil. Look inside an LS intake manifold, like a truck manifold. It's ridiculous. You can pour oil out of them if you've run them for a long time. Your Coyote's unopened. 420 wheel horsepower, though, nothing to write home about. That's good. Think about, there's a lot of cars, a lot of hot rod muscle cars not making 420 wheel horsepower. Enough at Ping Gun, anything less than 93. Yeah, they weren't as scared to throw timing at it. They weren't as scared. Flash Tuna is a Cosworth DFV similar to a Coyote with a carb. I know if I ever build an LS, it will have a cross ram. So then instead of me making, so what would you guys rather see? So I want to do a giant runner length intake so we can make maximum torque at like, I want to make off idle torque basically. So we got to have it at like 800 RPM, which would be really dumb. But so we want them to go all the way up to the roof and then back down, and then the plenums will sit on the side of it. So it'll be, it'd be a total of 12 feet or something. I don't know how long that is. It'd be a lot. So do I do that, or do I make it cross ram way out all the way across to the either side of the dyno cell? Let me know. Cross ram's kind of cool. Yeah, the Holley Skyram numbers, I was surprised. It didn't, it has a really big bump in one specific RPM range, but it didn't, I think that they didn't have it on a combination that they are also doing. The camshaft, I think, was not right for, had the wrong, did I have my wrong camshaft? Oh, the other guys. I think they had a bigger cam than if you would use that manifold with, if you were trying to make really low speed power. Whatever cross ram setup is easier to fit in the dyno cell. Well, it would be something that I make. It would be something that we make fit. But the longest one would definitely be up and down. I could have it go up and down and around and loop around and side to side cross ram with a Batman cat. No, what it would need to have is it need to have the giant cross ram and then either zoomies or even better, like 8-into-1 headers. Danny, I don't know why you're not getting notifications. Across the room and then back to the middle. Tried tuning 96 LT1 with Thundercat, brick 2 ECMs when standalone. Did it zap them? Could you see sparks and stuff? Can you get away with running solid roller lifters on a hydraulic roller cam? The Chris Craft Ford motors I got are solid lifter blocks. The cam grind I'd like to use as a hydraulic cam. What is a solid lifter block? Is it just an early block that used a flat tappet cam? I think if you made the current Super Ritchie a foot taller, that would give you the off-idle torque spike that you want. Well, and that's something we'd have to look at, because we'd be looking at, a lot of people don't realize you're looking at primary, secondary, and tertiary waves. So you, depending on when you get those coming in, it might be that the really long one doesn't work the way that you want it to. Ford 300 had very long intake runners. Yep. Just converted one of those to a single Weber. Come on, a DCOE. That's why they make those, so that it's a 6-cylinder. You got to put 3 of those on there. I think there's got to be a way to make long runners with a turn to help it with the secondary waves and give a bump low, mid, and higher in the range. You think a turn is going to do that? I honestly don't think reflected waves care about turns. $427 solid lifter blocks. Okay. Oh, is this an FE that you're talking about? Did I miss that? I was thinking that it was that it was just like a 351 or a 302 Ford. Is it then is it an FE then? 1 carb barrel per cylinder. Yep. Like to hear a flat plane crank with 80 to 1 headers. FE. Okay, that makes more sense. I get you. Dual quads on a V8, triple twins or dual triples on a 6, single quad on a 4. What I'd really like to have is I like those Crossboss intake manifolds for the Fords. I think those are awesome. Oh, so Burns, you're thinking that if it hits the turn, that some of the reflected wave some of the negative might reflect back as a positive, or vice versa? Where we put the turn, we'll just put a small notch in it too to help that situation. The problem is that creating that other minor wave, there's also lots of other waves going on in there anyway. there's lots of pressure cross homogenation going on in there. A cross ram that's built like a tri-Y header. An Offenhauser cross ram with a supercharger adapter plate. Mood had a cross ram for Chevy, usually Webers, but sometimes SUs. Do you guys remember the 4-barrel adapters that would bolt onto a 4-barrel intake manifold, and then the adapter went up to 2 side draft Webers on it? I can't see how that would be better than a carburetor. And I don't ever remember seeing any actual dyno testing of those to see if they worked or not. We're going to end our poll, but they look cool on especially guys put them on 2 of those on blowers and stuff. I got rid of our poll, by the way. Next project is a C10 LM7. For an Elm 7, I put a Truck Norris in it, especially if it's a driver. If you want to make more power, then you put something bigger in it. Which should make an actual intake plenum up for some of the available Speedmaster Weber ITB kits out there. A Ford Kentworth Webers. That sounds good. It's all chaos. It is all chaos. I wish that they could. I mean, I know that they could graphically show that, and it would be kind of cool. Kazi's finger test showed it pretty well. Can small turbos provide positive displacement supercharger like boost response at low RPM? Yes. Maybe not as immediate. Well, if you take a look at OEM turbo applications, you can have full boost at like 15 or 1600 RPM. So that's certainly possible if you want to do that. The 413 Chrysler Cross Ram is cool also. Steve, in Australia, they use a lot of Cross Ram ITBs. They have some cool ones there. One that went from one side of the dyno cell to the other would be good, yeah. I could ask Dulcich if I can borrow a 440 or something from him. Admiral, if you're gonna do it's a big block Ford. Did guys even make like Crowder or Hilborn or that kind of stack injection for it? One more minute. Oh, Speedmaster makes a big block Ford one. White Aussies get all the cool stuff. They really do. They get a lot of cool stuff there. So shout out to my Aussie brethren. On that note, I will see you guys all tomorrow. Be safe out there, make good choices. So you're all here tomorrow. And now so you guys have a good Saturday or another day if you're in another part of the world. And I'll see you guys all tomorrow. Bam, 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 bam.